Assalamu alaikum again. Welcome to Practical Numerical Methods for Scientists and Engineers. And we still in Module 3, Roots of Single Equation, and we will continue to Newton-Raphson method. And as you know, Newton-Raphson method is an open method. So here in Newton, we use only one guess. So the idea of Newton-Raphson is that it uses the tangent of lines. The tangent lines extend from 2 points x and f of x, okay, to determine the improved estimate of the root. So suppose that this is my f of x, okay, and this is the tangent, okay. So and this is the so now I have 2 points. I have here 2 points of this tangent. I have f of x and here xi. Then I xi plus 1 cut the x-axis, okay. So here I can find the slope. So the slope is f of xi minus f of xi plus 1 divided by overall xi minus xi minus 1. Keep in mind that this one should be equal 0. Okay, then the slope or the f dash xi equal to f xi minus 0 over xi minus xi plus 1. Okay, so then by rearranging I can get xi plus 1 equal xi minus f of x over f dash x. So this is the derivative of this function. Okay, so I can use this equation to as iteration to get improved estimate of root every time. Okay, so now, so what is the input? So the input is x, okay, this is my input, okay, and I need the f of x similar to bisection, but here I need the derivation of this equation, okay, so it will be f dash xi. Then the new x will be calculated based on this equation to find the new solution, improved solution, and until I reach the maximum iteration or the maximum error required. Okay, so now let's go for the next slide. Okay, now, so we have initial guess of x, we have f of x, we have f derivative of x, fx, we have relative error and maximum number of iterations. These are the inputs. The output is the improved estimate of x or failure message if he couldn't find. Then the iteration steps, we'll consider I, we will use while I equal 1 to iterate to do the steps from to B and C. We will discuss later what's B and C. Okay, so this B and C. So then set x equal x naught minus f x over x f dash x naught, and then if the maximum if the maximum number of if the relative error is reached, okay, then output x stop, and otherwise failure message. So let's try it here. Okay, now this is input. So input will be x f equal input, put the equation, okay, and remember if you want to put the equation you should add x and put your equation, and then df also it's another equation, the derivative equation, and then we need to put the x naught, the initial guess. Okay, and then here we need to a relative error required, and here the maximum iteration. Okay, now let's start. So we said we should put these things outside, so now we have I equal 1, and while I minimum or less than the iteration, do the following. So that means the loop will stop if the I become equal to the number of iteration you use. Okay, so while I less than iteration, then here we can apply this equation, x equal x naught. Remember that every item here, variable here, should be identified before. If you put something here that is not identified before, then you will get an error message. So okay, x equal x naught, this is the initial guess, minus f of x naught over df of x naught. Okay, then find the relative error. Relative error will be abs x naught minus x minus x naught over O. Okay, here this is new code. Okay, that I and all columns in that I, and these columns in that I extract. This is extract. Okay, so what all columns here? It will be I XO XFX. So this data will be recorded. Okay, so it will be recorded every time and keep it. Okay, so it will be like I XO X and f of x. So it will be extracted for the I and all columns. Okay, so here I1, and then I2, then I3, and so on. So it will be extracted every time. Now if relative error are less or equal than relative error defined here, then break and end. Break the while code. If not, of course, I equal I plus 1. So this means continue. And x naught equal x. So he will continue the loop again. Then end. Then that. So it will show the all table will all contain, and then f print f the estimate equation of put the x, and the relative error is, and for number of iterations I. So if we did this, we will get, okay, here insert the equation. Remember that again, we put add x between parentheses and put the equation. This is the derivative equation. Okay, this is the estimate root 2.2, the relative error is 0.1, and the maximum iteration is 5. So the solution reach in only 3 iterations. That 1 1 1 you know already. Sorry, we know already what is that. So this one x, you can put, if you want, you can put here before that display. Sorry, we can put display and put identify these items before put that. You can do it by yourself. Okay, so then the estimated root of equation is, and the relative error is this one. Okay, in 3 iterations. So that's all for today tutorial, and thank you. See you in next tutorial.